Greetings. Today we are going to calibrate an Alpha Omega Instrument Series 3000 Trace Oxygen Analyzer. The Series 3000 in this video is capable of measuring oxygen concentrations over three ranges: 0 to 100 ppm, 0 to 1000 ppm, and 0 to 10,000 ppm. Our calibration gas has been certified to have a concentration of 779 ppm of oxygen with the balance of nitrogen. Please keep in mind that the oxygen value of the calibration gas you decide upon can be different as long as it falls within the overall range of your Series 3000. At the onset of the calibration procedure, we recommend that the analyzer be powered for approximately 10 minutes. The analyzer shown here is being used to measure ultra-pure grade nitrogen with an oxygen value of less than 1 ppm. The sample flow rate is approximately 300 cc's per minute. By the way, the exact flow rate used when calibrating the Series 3000 is not important, as long as it is between 100 and 1200 cc's per minute. This Series 3000 is reading 0.4 ppm on the ultra-pure nitrogen gas, which validates that this gas delivery system is free of any air leaks. The calibration gas delivery system has likewise been tested. To drive home this point, breathing air contains 209,000 ppm of oxygen, so it's easy to appreciate that a tiny leak of air into the calibration gas can elevate the oxygen readings, resulting in an incorrectly calibrated analyzer. Air leaks typically result from either loose fittings, poor gas connections, and/or the use of porous plastic tubing such as Tygon to deliver the sample gas. I can't emphasize enough the importance of using either copper or stainless steel tubing to deliver the calibration gas to the analyzer. Once you are convinced that the sample delivery systems are free of air leaks, it's time to connect the calibration gas for the final steps in the process. Please keep the isolation valves closed whenever you're changing the sample gas feed to the analyzer. As you can see, I am closing the valves in anticipation of connecting my calibration gas. As I mentioned previously, the calibration gas being used for this demonstration is certified by our supplier of calibration gas to contain 779 ppm of oxygen with the balance of nitrogen. I have connected the sample line and am now supplying the calibration gas to the Series 3000 at approximately 300 cc's per minute. I recommend waiting for approximately 15 minutes to allow stabilization of the oxygen reading. The oxygen value displayed on the instrument is 735 ppm. However, we know the gas contains 779 ppm of oxygen. Therefore, an instrument calibration is in order. To begin the adjustment process, first, simultaneously press alarm buttons 1, 2, and 3. The digital readout display will continue to show the now stable oxygen value and will also show an alternating cal message in the display. This means that the instrument is in calibration mode. Next, using the up or down arrow push buttons, press the appropriate button to adjust the display to read the 779 ppm value of the certified gas. In this case, I will use the up arrow to increase the reading. Now that the analyzer is reading identical to the calibration gas, simultaneously press alarms 1, 2, and 3 again. The alternating cal message disappears, and your Series 3000 is now fully calibrated. When finished, the manual isolation valves should be closed for instrument storage. In addition, closing the valves also helps to avoid prolonged exposure of the sensor to air. For the procedure we just performed, we used gas that was under positive pressure. Consequently, we highly recommend that the upstream valve be closed first, followed immediately by the downstream valve as shown. This will help avoid an inadvertent overpressurization of the sensor. I hope you found this video helpful.